All right, hey guys, today we are talking about the last section of this next test that we're going to take, right? We talked about sine and cosine and tangent functions, trig functions to find a missing side of a right triangle. And so today we're going to talk about finding the angles, because sometimes we need to find all the angles and all the sides in order to solve a right triangle, right? So that's what we're going to do today. So remember our mnemonic, right? That's SOHCAHTOA, but we know that sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, okay? SOHCAHTOA. So to find the inside measure of a right triangle, we're going to use an inverse function, okay? So how you enter this on your calculator, you hit second, and then where the trig function button is, above it, you'll notice the inverse function, right? So above sine, you see sine inverse. Above cosine, you see cosine inverse. And above tangent, you see tangent inverse. But the ratio is still the same. The thing is, you need to have both of these sides given, and you can find the measure of that angle. I'll show you a couple examples and it'll make sense. So sine inverse for the angle that you're looking for, you need to have the opposite and the hypotenuse from that angle. And then if you were using cosine, you need to have the adjacent side and the hypotenuse from the angle you're looking for. All right, so let's take a look at some examples, and then I think you should be okay. If you're okay with the trig ratios as they are, remember it's SOHCAHTOA. All right, we use regular trig functions to find the outsides, the sides. We use inverse trig functions to find the angles on inside the triangle. All right, here we go. Now we're going to solve this right triangle. First off, we need to find the length of AB. So, AB. Again, this is a right triangle. We can still use the Pythagorean theorem. That's totally fine, right? 8 squared plus 4 squared equals, let's just call this x squared, right? 64 plus 16 equals x squared. Oh, why did I write 8? Because I'm silly. 64 plus 16 is 80. That is equal to x squared. All right, now we just need to take the square root of both sides, and we're going to round to one decimal place. So the square root of 80 is 8.94. So that makes AB 8.9. There aren't any units given like centimeters, inches, feet in this example, so we're just going to write it 8.9. Okay? I'm just going to finish this here. X equals 8.9. Well, I actually should use the little squiggly equal sign because it's not exact. You know, we don't want to be like, oh. Anyway, all right. Now we need to find angles. So at this point, you get to choose, do you want to find angle A or do you want to find angle B? So I'm going to look for angle A. So from angle A, I have the opposite side and I have the adjacent side. So let's refer back, right? SOHCAHTOA, tangent is opposite over adjacent. Remember, we're looking for the angle which is inside, so we say tangent inverse of the ratio 4 over 8. Right? Get out your calculator, hit second tan, 4 divided by 8, enter. And you should get 26.565, blah, blah, blah. But we're going to round to one decimal place. That gives us 26.6 degrees. 26.6 degrees. So we can say the measure of angle A is 26.6. The last thing we need is the measure of angle B. And let's work smarter, not harder, right? We know the interior sum of a right triangle is 180. We know the measure of angle C is 90. So that makes A and B complementary. So 90 minus 26.6 is going to give us the measure of angle B. So 90 minus 26.6 is 63.4. So 63.4 degrees. Oh, and I forgot to write my degrees for angle A. All right, and there we have solved, we know all the sides and all the measures of the angles of this triangle. All right, let's check out another example. All right, here again, I'm missing the hypotenuse, so I'm just going to make it C this time. So, C squared equals 3 squared plus 2 squared, right? So 9 plus 4 is 13. And I take the square root of both sides. I get C is equal to 3.6. I'm just going to write this down on the side and keep it equal so you can see. All right, now I'm going to find angle B this time. Right? From angle B, I have opposite and I have adjacent. Again, I have to use tangent to find the measure of angle B. But inverse tangent, because we're finding inside. So tangent inverse of 2 over 3 is going to give us the measure of angle B. Remember, you're rounding to the nearest tenth, so second tan, 2 divided by 3 is 33.7 degrees, right? So measure of angle B is 33.7 degrees. All we need to do to find the measure of angle A is subtract. So 90 minus 33.7 gives us 56.3. 56.3 degrees. All right, totally cool. Now this triangle's all solved. Let's check out another example where we're not missing the hypotenuse. All right, here we're missing the side opposite of the angle given and the side adjacent of it. So opposite, adjacent. I'm not going to use tangent because I need to know at least something here. What I know is the hypotenuse. So I'm going to use sine and cosine to find Q and P. So first, let's find Q. It's opposite. I have the hypotenuse. That is sine. Opposite over hypotenuse. So sine of 53 is equal to the ratio of Q over 30. Right, we multiply both sides by 30 and I get Q is equal to 30 times sine of 53. All right, so I'm just going to write Q equals. Here we go. Let's plug it in. So 30 times sine of 53 is 29.59. When I round to the nearest tenth, that makes this number go to 24. So this is 24. So that side length is 24. Now let's find P. P is adjacent. I have hypotenuse. Adjacent over hypotenuse is cosine. Adjacent over hypotenuse. So let's set it up. Cosine of 53 degrees is equal to the ratio of adjacent, which is P, over hypotenuse, 30. Again, I'm going to do the same thing, right? Multiply both sides by 30 and get P is equal to 30 times cosine of 53. All right, let's check it out. 30 times cosine of 53, and I get 18.1. And I round to the nearest tenth. So P is 18.1. All right, the only thing I'm missing is angle P. So this is lowercase p, now I'm looking for capital, measure of uppercase P, so the measure of angle P is complementary to Q, so 90 minus the measure of Q, right? 90 minus 53 gives us 37 degrees. So P is 37 degrees. Yay, we solved that triangle. That wasn't so bad, right? All right, so here we have a triangle with two missing sides. We're missing the opposite side of the angle given, and we're missing the hypotenuse. So first thing, you're like, what do you have? You have the adjacent side. 8 is adjacent to 31 degrees, okay? So F is the hypotenuse and E is opposite. So if we write our SOHCAHTOA down, we should know which trig functions I'm going to use to find the missing sides. All right, so let's just go for E first. I'm looking for E. That is opposite. I have adjacent. Opposite adjacent is tangent. So tangent of 31 is E over 8. Multiply both sides by 8, and I get E is equal to 8 times tangent of 31. All right, let's plug that in. And I get 41.8. No, not 41.8, I'm sorry. 4.8. You should get 4.8 too. All right, so E equals 4.8. Let's find F. All right, so F is the hypotenuse. I have adjacent. Adjacent hypotenuse is cosine. I have to use cosine to find F. So cosine of 31 degrees is adjacent 8 over hypotenuse, which is F. All right, in this case, remember I told you the shortcut. If you have the variable in the denominator, you can just change places because it saves us a bunch of steps. So F equals 8 divided by cosine of 31. You put that in your calculator. 8 divided by cosine of 31, and I get 9.3. 9.3. So F equals 9.3. All right, the last thing I'm missing is the measure of angle D. And we should know that this one's really easy to find. You want to use inverse trig functions because they're fun? You can do that. But we can also just subtract, right? 90 minus 31 equals 59. So the measure of angle D is 59 degrees. Nice. Now, triangle solved. Boom, moving on. I got 2 more examples. I hope you guys are taking notes. And if I'm going too fast, pause the video. Rewind it. Watch it again. It's good for you. The test is on Tuesday and Wednesday, and I want you to be ready. All right? So now here we go. Another fancy triangle. I'm missing a lot of information, but I have some information. Let's first find the angles, okay? You get to pick. You want to find angle A? Okay, that's cool. What do I have from A? I have the opposite side, and I have the hypotenuse. Opposite hypotenuse sounds like sine, right? Sine is opposite over hypotenuse. I'll just write the rest of my stuff here so I don't have to do it again. So remember, we use inverse functions to find the angle inside the triangle. So inverse sine looks like that of the ratio 10 over 12. Right, we get our fancy little calculators. Let's plug that in. Second sine 10 divided by 12, and I get 56.4. Cool, I'm fine with that, right? So the measure of angle A is 56.4 degrees. Right? The measure of angle B is just a simple subtraction away. That's nothing we can't handle, right? Right? The measure of angle B is nothing more than 90 minus 56.4 degrees. It gives us 33.6. And now we just are missing a side, right? Let's just call this side little b, right? We're looking for b. So we can use the Pythagorean theorem again, right? B squared plus 10 squared equals 12 squared. So b squared equals 100. B squared plus 100 equals 144. B squared equals 44. Let's just keep going with round to the nearest tenth because that's nice. I know you guys like taking a break from those radicals. So square root of 44 is approximately 6.6. So B equals 6.6. Or side. So let's just, no, I already went with sorry. AC is equal to 6.6. Now I have solved this triangle. We are just killing it. I hope you guys are loving it. One more example and you're good to go. Okay, so we have a lot of information. I love when we get ones that have one angle because that gives me some direction. I see that the measure of angle H is 25 degrees. I see the hypotenuse is 13. I'm missing the adjacent. I'm missing the opposite. So let's just put this SOHCAHTOA down. Right, this is our little legend or key, I guess, that you have on a map, right? Okay, so from 25 degrees, H is opposite, G is adjacent, okay, and C is the hypotenuse. So again, you get to choose. You want to find G or H first? Whatever, just pick one, okay? So let's go with G. So I want to find G, that's adjacent. I have the hypotenuse. I have to use cosine. So cosine 25 is G over 13. G is equal to 13 times cosine because we multiply both sides by 13. All right, we put that in. And I get 11.8 about. So G equals 11.8. Let's find H, okay? H is opposite. I have hypotenuse. I'm going to use sine. So sine of 25 degrees is equal to H over 13. Again, same operation. Clear the fraction. Get H by itself, right? H equals 13 times sine of 25. Bust out our fancy little calculators and plug it in. 13 times sine of 25 is 5.5. All right, so H equals 5.5. All right, now we just need to find the measure of G. That's so easy. It's just simple subtraction, right? 90 minus the given angle. I love when they give us the angles. Is 25, okay? 90 minus 25. 65. That gives us the measure of angle G is 65 degrees. And now this triangle is solved. There we go. All right, sweet. So today, how much time you have left, here is your assignment for tomorrow. It's due on Monday, by Monday morning. If you have any questions, send me a message on Schoology. I'll do my very best to assist. We're going to do a review on Monday, and then you will have a test on Tuesday and Wednesday. Remember, they're half days, so it's a condensed time. So I want to make sure you have enough time to answer all your questions. All right, have a great weekend.